warahmatullahi wabarakatuh. I'm Yusri Shamsudin. I want to present about a video insect pest. Its name is Termites for subject crop insect management AGR 464. This is the contents what I want to present about it. First is introduction of insect pest. Is what is Termites, the symptom, what is effect for the yield and plants, and how to control and practice, and then a conclusion and also a reference. Before we continue, we must know about the introduction of insect pest. Insect pest is a living organism or insect that feed on, compete for foods with or transmit disease to human, livestock and crop. 1 million species of insect, only few thousand as insect pests, they are very damaging. So now we're going on to what is termite. Termite are social insects that live in a small to large colony. A colony in some species contain almost a million or more individuals. These insects are well known as a vital component in the breakdown of the dead timber and vegetation. The recent information and identification of termite species in Malaysia, we refer to the Peninsula Malaysia and Tapal Sabah. About 175 species of termite was recorded from 43 genera from the three families Termitidae, Rhinotermitidae and Termitidae in Peninsula Malaysia. So now, what is Termites? Termites or horngrams from the genus Termites is a destructive termite species of a tree plantation in Southeast Asia and attack live tree. Termites is a subterranean termite species belonging to the genus Termites in the family of Rhinotermitidae. There are two types, which is one is subterranean inside the soil, and also another is arboreal, which is in the plants, as we can see as the image. So as the image, you can see what is different about anatomy of the Termites, Termites supergensis, Termites Cashsovini. So we can see from the mandible, fontanelles, head width and pronotum is different. So now we can see about anatomy. We can see anatomy of the termite is they have salivary glands for good, big good, cellulose digestion, and also entry valve, bacterial enzyme such as citinases, glucanases, cellulases, amylacelases, and also you have a hydrolyzed amorphous cellulose and minor lignin modification and hindgut and also the rectum. So this is the anatomy of the termite. So the termite, we can see they have a structure for the system life. So they have a male and also a female. They have a primary king and also primary queen, which is they have the dispersion nymphoids, Netonic king and Netonic queens, and also they have a workers for that. They are nymph. They can make a soldier for their work as a unity. Okay, now we go to the life cycle. In life cycle, we know is a male and also a queens. They produce an egg. After the egg, they can go to youngest nymphs. Youngest nymph can being to the older nymphs. Older nymph, they decide how it could be such as workers, soldier, and the reproductive nymph. So it can be ellets reproductive, ellets reproductive, and also supplementary reproductive worker or soldiers. So if we can see the top of nest, see the lower termites. So there has a connection, lateral connectivity inside the nest. So the system in the nest So you can see chine and combs. So you can see like the image how the system beat it inside the soil for the termites.
I'm now at a Jengka.This plantation. I want to find a termites here. What the effect termite for the plant of the plantation. So let's go.
If we can see the image, the symptom the presence of termite usually found in the area where the land clearing not properly executed, and the log stump is often left in the field. This unattended log stump serves as a source of food for termite and the nesting site them. Termite can attack all age of the oil palm tree. The attack can be found as early as 6 months after planting. The presence of mud trail or palm trunk and petiole is one of the obvious indicators to the tree infested by termite. Common foliar symptoms will be detected when leaves on the lower frond yellowing and dying. The incident occurred when the soil was drying up and the food source, especially the logs that were buried in the soil, rotten up. How it affect the yield and plants? So we go to damage to immature plants first. Feeding damage, immature oil palm trees are susceptible to termite attack. The termite feed on the apical meristem at the base of the spears, potentially killing the young palm. Hollowing out, the termite hollow out the hardwoods of the trunk, reducing timber value.
Leaf will be grow, so not grow well, turn to yellow, and the quality of yield not good because the part of the inside of the plants damaged because of the mines.
This is the image. We can see what is going to happen when the termite attack the plant, the oil palm. So the young palm, we can see the leaf kind of growing well. So the mature palm, we can see a trunk damage. So the system of workers of pest termite very hard working to do for their food, and they damage the plants.
Plants we effect the damage from because of termites. You can see here. You can see damage from the trunk because of the termite. The termite need a source of food, so that they build up the nest below the plants. So they attack slowly, and the roots, the termite go up and eat the source of food, and then the plants cannot grow well because of the termite damage.
There are the stage, which is initial stage. We found the presence of fresh mudwork, spear on front or steel greens. So the intermediate stage, discoloration of spear, and upper two young fruit turn to yellowish brown, and advanced stage, spear and upper front start to dry, up turning brown, finally spear become rotten and collapse. What are we doing? How we want to control it and practice. One is the UiTM of termites. So we know the termites from the early warning system, cancers, which is visual observation, which is we can see a fresh mud, we visual it. So we baiting with rubber wood stick and corrugate cardboard in termite detector station. Then after that we mark infested and 6 adjacent palms to avoid new infestation at nearest palm. So after that we treat with chemicals, scrap the mud work, and to improve penetration, avoid and dry season. Other than IPMs or baiting the termites, we can use a chemical control, such as familiar is with fipronil and chloropyrifos, which is we use around every 6 months, 3 or 6 months, spraying of drenching, baiting and spraying drenching. So the method of the fipronil and sugarfil, we just spray around the mud work and we control the population of the termite. Another ones we can control by a biological control, which is we do increased water tables can force termite to surface. So BMP pit water level 50 to 70 meter around the plants, adjustable weight made from sand bed to increase water table 50 to 30 cm. So the termite can grow, cannot support, and maybe they can reduce the termite from that area. And also others method to control is we must clear the land infected for the termite. So we destroy food source, the termite food source. Then we do a mechanism and it's soft-like kill. For the conclusion, Cotyledonous cavinetus pose a significant challenge in oil palm cultivation. Understanding in behavior, implementing effective countermeasure is most important, and monitoring termite activity are crucial for sustaining healthy oil palm plantation. Lastly, this is some reference that I refer for do my task. This one is sawitsecure.mpob. Pest open oystering toward eco-friendly, integrated pest management for termites, and notes in class AGR 499 with Dr. Noah Slinda. Thank you for watching, and Assalamualaikum warahmatullahi wabarakatuh.